All right, we're working with solving questions using Vertex form. So you guys have seen Vertex form before. We've been using it to transform quadratics along the graph. We haven't really used it too much algebraically, though. We've been given two forms of a quadratic. One of them is in Vertex form. Can you tell which one it is?
Yeah.
Which one?
GW.
GW, all right. This one is in our Vertex form. Okay. And what form would you say the other one is in? It's a little harder to tell. That's right. It is in standard form, actually. Okay. And what we're going to do here is we kind of want to see, do we have two different equations? Okay. So are there two different equations here? Well, what we're going to do is we're going to try to turn Vertex into standard form to test this out and see if it's the same equation. What process do we use to do that? Anyone know?
We distribute W minus 20 squared.
Yeah, that's right. It's also known as expanding. Okay? And that's the exact same process that we use to turn factored into standard form. So we're going to take our GW and we're going to expand this question.
Yeah.
Okay, so we take our GW. We're going to expand it to see if that's truly what this standard form is. So we have negative W minus 20 squared plus 400. Well, those brackets essentially mean W minus 20 times itself. Okay. Then we distribute those. We'll keep this negative on the outside. And when we FOIL this, we're going to left with, and I'm going to kind of skip a step here so you guys follow along. We have W squared. It's going to be minus 40W and then plus 400. Okay. Then I got to make everything negative. That's right. We have to distribute that negative term to everything. So when we distribute the negative, we're going to get negative W squared plus 40W minus 400 plus 400. What happens to those two constant terms at the end? Cancel out, and what do we have?
Same as the standard one.
That's right. So these are actually representing the exact same quadratic. They've just been shown to us in different forms. Okay? Now let's say we wanted to find... Now the vertex is very simple to find because we already have the vertex. Okay? We're going to relate how to find the vertex in standard form, which we've done a little before. There's a process to it. And then we're going to talk about how we can find X intercepts using vertex form. Okay? So, standard form, to find a vertex, what is the process from our standard form here? So we're now in standard. Yeah, Mitch? Okay, we'll have to find the zeros for the X intercepts, right? And in order to do that, what do we have to do to this? That's right, we need to factor it. So I'm going to quickly factor it. Now, first thing, what's the very first step of factoring? Anyone remember? Common factor. What would be a common factor here? Negative W, exactly. So I'm going to do this part in blue now. So we have negative W comes out, and we'll be left with W minus 40. Okay. And now we have a factored form. Now remember, this is still equal to our GW. If we're trying to find x-intercepts, we set GW equal to what? 0. And then we'll have negative W times the bracket is equal to 0. So we split the equation from here. So you remember this from your test. We have negative W equals 0, which means W equals 0. And we have W minus 40 equals 0, which means W equals 40. We found two x-intercepts. How can we find the vertex from here? That's right. So we get our axis of symmetry, AOS. We add the two the x-intercepts together, so it's 0 plus 40 divided by 2, which is going to give us
20, I think.
Right? 20. Okay. And then to find out that's the x value of the vertex. To find out the y, we
plug it in.
That's right, we plug it back in. So let's actually take our factored form here, this one here, and we'll plug it right into that. We have G, when G is W, not when G is W. When W is 20, Okay. Our equation is equal to, and I'm writing this in function notation, this becomes negative 20 times 20 minus 40. Minus 40. We'll simplify that bracket, and we're going to get negative times 20 times negative 20. Anyone know what that's going to equal? Positive 400. So in other words, our vertex is 20 and 400. Let's quickly jump up to our vertex form. Does that make sense?
Yeah.
That's exactly what our vertex is. But let's say we had vertex form and we didn't have the standard form. We wanted to find the X intercepts. We already know the vertex. That's very simple. We could still use vertex form to find X intercepts. Now this process is a little different. I'm just going to do it on the right here. So I'll put this line down the middle to kind of separate it. I guess we'll do this one in red. GW is equal to, I just got to rewrite the vertex, negative W minus 20, W minus 20, is it plus 400? Yeah. Okay, to find X-intercepts, our Y value needs to be equal to what? 0, okay? So the exact same thing we've done over there. We're going to take GW and make it equal to 0. So we have 0 is equal to negative W minus 20 squared plus 400. The goal is to isolate our variable. Well, luckily, in vertex form, we only have one variable. So we don't have to do any factoring. We just kind of got to isolate that variable. So we start moving things to the other side. When I move 400 to the other side, what will it become?
Negative 400.
Right? We get negative 400, okay, because it's 0, subtract 400, is equal to negative W minus 20 squared. Now, what would be the next step here? What do I move? I don't want to expand, actually. If I expand, I'm going to get a W squared and a W, and I'll have to end up factoring. Okay. When we're trying to isolate for one variable, we do something usually known as reverse bedmass. You know, in bedmass, we deal with the brackets first, and then we do adding, subtracting last. When you're isolating, you kind of do the opposite of that. Okay. What we do here is we take our adding, and we brought that to the other side. That was the very first step. The next thing would be the multiplication, because that's the next lowest on the list. So this negative, or negative 1 that needs to be distributed, we're going to move that to the other side. In order to move it, I need to divide both sides by the value of negative 1. That's right. We're going to have 400 is now equal to W minus 20 squared. And then, according to bed mass, if we're doing reverse bed mass, we have an exponent and a bracket. Let's deal with the exponent. What would be the opposite operation of a squared value?
Square root.
Square root. So we need to square root both sides. Now, when we square root both sides, the side on the right, we're going to be left with just W minus 20. We've essentially got rid of those brackets. These two cancel out. Now, when I square root 400, what will I get? 20, but there's technically two answers. It's not just 20 or positive 20. Okay? There are two values that will multiply to positive 400. Positive 20 and negative 20. So we get two answers here. So at this point, just like when we factored, okay, so we'll draw just a little comparison here. Just like when we factored here and we had to split the equation, we'll do the exact same here. We're going to split the equation. The equation is going to read positive 20 is equal to W minus 20, and negative 20 is equal to W minus 20. Okay? Same idea as factoring, but because we have two answers, we don't have to split. We have to get for two different answers. So we bring the other 20 over here, and we're going to get W, that's going to be 20 plus 20 is equal to 40. And when we bring the 20 over here, it's going to be addition, and in this case, we're going to get W is equal to 0, which are the exact same X-intercepts we had found before. So we could still solve using vertex form, the process is just a little different.